Okay, so welcome to Arup, everyone. Thank you very much for coming. I'm just going to quickly introduce Arup and explain why we wanted to be involved in this project before Yiu takes over and explains about the project. Okay, so we'll get started. A little bit about Arup then. So Arup as a firm was founded in 1946 by an engineering philosopher, Ove Arup. Ove was primarily a structural engineer, and in the early days Arup was effectively a structural engineering firm. He initially made his name as a structural engineer on the Sydney Opera House, which was a bit of a very difficult project, and through that basically was able to get this project built, which at one point it didn't look like it was going to be possible. The firm gradually grew in size, diversified into a number of different areas, and then in 1980, by this time we've taken on a number of architects, and in 1980 the firm was appointed to design the Snape Maltings concert hall, and basically it was out of that project that Arup Acoustics was born. So over the last 35 years since Arup Acoustics was born, again the firm has grown significantly. We now have over 12,000 people in 92 offices in about 40 countries, and approximately 150 acoustic consultants around the world now in the UK, Europe, North America, and Australia. The nice offices we have acoustics teams in. Now, when Ove retired, he decided he was going to leave the company in trust to the employees. So effectively, the company is employee owned, and that structure allows us to think a little bit slightly differently. We're not sort of entirely focused on profit. The profits that the company do make are effectively reinvested in the company, either through research or sort of putting it into the bank for a rainy day to help the company through difficult times, and also to the employees in terms of the profit share. But that money that's reinvested in terms of research is put into a fund that basically anyone in the company can apply for that funding, and that's basically how 15 years ago the Arup Sound Lab was born. Some funding was applied for in New York. The Sound Lab was built. A number of a lot of work kind of projects were done with that, and we now have 11 of them around the world. The newest of which is here in Manchester, which I'm sure we'll all get to see over the next day and a half. So we used to use Auralisation specifically for building acoustics projects, for particularly performing arts buildings, concert halls, theatres. We now use it extensively for environmental and infrastructure projects as well. We used it quite a bit on HS2 to help people understand what high-speed trains might sound like close to their house. So we sort of took a number of locations, recordings, and overlaid recordings of high-speed trains which we'd modified, but we married all this with CGI that our visuals team was involved with, and about 25,000 people experienced that over headphones on the Consultation Roadshow. And it really shows. We're now using the same technology now to auralise aircraft, and how changes to flight paths can sort of shape a commuter's response to noise. So really using auralisation to try and engage with people. And of course, like most consultancies, we use computer modelling quite extensively. We have Odeon and CAT, sound plan, and those sorts of things. And modelling is often the starting point of our auralisations, really. So the more accurate our models can be, the more value we can offer our clients, and the better auralisations and stakeholder engagement is, basically. And so, given the structure of the company now, kind of interested in investing in research. We've invested we sponsor PhD students. I mean, Ian's there. You'll do a talk this afternoon? Tomorrow? This afternoon? Today. Coupled with our use of modelling and auralisations is why we were very keen to get involved in this project. Really, we saw an opportunity to be involved in the project, looking at accuracy of modelling, how that can be improved, how that can feed into auralisation, and as a consultancy, we felt it was something that we'd like to be involved with. So I think Yiu is going to take over and explain a bit about the project itself.
Wow, just a very brief one. Right. Okay. Thank you for coming. And I think we have 1.5 days, so hopefully by the end, I think everybody will know each other. And although at the moment I don't have my glasses on, so I can't recognize most of the people. So excuse me if I stare at your blast to your nameplate just to make sure that I don't mistaken anybody. So welcome to this one. As the workshop is sort of the title is looking at sort of acoustic simulation and auralisation, and the purpose of the workshop really is trying to bring together sort of people working or academic researchers or industrial researchers together with people who develop software for sort of acoustic simulation and auralisation, and also sort of engage the user and the sort of practitioners like Arup and sort of Rambo and other companies, and to really trying to look at the state of the art of the acoustic simulations and auralisation, and then sort of we would have a workshop or a discussion panel tomorrow to actually look at what future direction we should take, and whether there are any sort of collaboration opportunities that we have. So this is the main sort of purpose. And we sort of, this workshop sort of come out from a EPSRC funded, EPSRC stands for the Engineering and Physical Science Research Council in UK. And there is a sort of a funded research project for looking at how to enhance the acoustic sort of modeling and auralisation using hybrid sort of band. And Jonathan here is our research fellow working on that project, and he would sort of give a bit more detail about exactly what we do. But basically, what we want to sort of try to look at is how to bridge the low frequency capability of sort of method like sort of boundary element method and the high frequency sort of speed of the efficiency of the geometrical method. And we already had a workshop in Reading last year, hosted by Steve, our sort of collaborator from University of Reading, and that one is more focused on the mathematics and the sort of theoretical side. So it's mostly involved sort of academic researchers, and but this workshop is trying to extend it sort of and get more sort of practitioners and users involved in the discussions. So that's the purpose of the workshop, and the program. I think you have all been given the sort of program already, so I'm just going it sort of very quickly. And we will have technical talks, which cover sort of different simulation methods, and during which we also will have some demos, and they are sort of integrated together with the refreshment time, so you can have your coffee and listen to demo at the same time. And and there are also demos that are in here, which I think the table. So at the back is for people to set up their laptop and whatever for the demo in this room. And so we start sort of this workshop today, this sort of afternoon, and we hope to finish at around sort of 6:30, something around that time. Actually, I got the program on the Alex page. And then we will have a dinner sort of nearby. And then we start again tomorrow and finish the afternoon with 2 discussion panels. So I think this is really just a reproduction of the leaflets that you already get. So this is sort of how we arrange the things for the Sept today. Okay, so since it's funded by EPSRC, coming out from this project, so shamelessly, I'm going to talk a little bit about our project first and do a bit of promotion kind of thing. And the title of our project is about sort of enhanced acoustic modeling for auralisation using hybrid boundary integral method. And this is a collaboration between us and University of Salford and also University of Reading. And it's funded by the EPSRC, and we have 2 industrial partners, Arup and the BBC. And BBC sort of don't have a sort of a representative here today, because I think they are more interested in the audio rendering side of things rather than the sort of more room acoustic sort of auralisation side. And as a summary, as I say, the detail John is going to talk about, but basically what we are trying to look at is that if we look at the current state of the art, so to speak, we have at the high frequency end, sort of more geometrically based method, and on the lower frequency end, we have the more wave-based method. Now there are already, of course, a lot of work that are trying to extend the frequency range of those 2 groups of methods either way. And on the geometrical method, sort of like Peter is doing, so looking at the sort of diffraction integrals, how to incorporating it into the sort of geometrical method. And then at the late time, you've got the more heuristic model of diffractions and kind of thing. And on the the wave method side, we have enriched method, which our project is sort of belong to this group, which, as I say, John will talk a little bit more. And the finite element method side also have similar development, and also, of course, the finite difference time domain, which is particularly suitable for parallel sort of computing. And so what our project is trying to bridge this side, and we are mainly working with the boundary element method, so it's mainly focused on this one, and try to actually combine the two, or find some way of combining the two, not quite combining, make use of the characteristic of each one to actually try to sort of extend it to a full auditable sort of bandwidth. And by so combining the advantage of both methods, we should be able to actually have a more user controllable sort of compromise between the accuracy and the efficiency of the method. So basically, the aim of the project is to undertake the sort of mathematical and numerical sort of development necessary to actually look at the acoustic modeling algorithm to deliver that. And we'll implement the algorithm, which again, as I say, John would talk a little bit. And now this part is a little bit more in the future. We hope that sort of this algorithm would sort of be able to let us improve the auralisation process. And then, of course, that is the reason why we have this workshop, is to disseminate the new findings to a wider community and audience. And obviously, in order to do that, we want to bring together everybody so that we have a good representation of the state of the art. And John said that I shouldn't talk too much of this one because he's going to talk about this in his sort of slides and whatever. But these are just some of the things that sort of we have done so far. I leave it for John to actually do the detail. And but in terms of further work, future work, I think to me is also sort of one of the important things for us sort of in this workshop. Although our own projects or our idea is that sort of the two directions that we want to take is to sort of a little bit more on the detail of the algorithm and also moving it to the time domain. But we also want to look at or to see what sort of other ideas that sort of the audience might have in sort of what are the actual best direction to take for the future work. And again, because we host this together with Arup, and we need to talk a little bit about Salford and also our work that we are doing at the moment. Just take sort of 3 examples which are related to the auralisation side and the simulation side. And the first one is a program grant that we are working together with, again, BBC and the University of Southampton and also University of Surrey. It's a 5-year program grant to look at the sort of future spatial audio. I think S3 stands for the Free University, wouldn't it? And now in Salford, what we are focusing on is on the perception side. I think Philip might sort of correct me. I think in Southampton, you're more focusing on the modeling and the signal processing side?
Your reproduction.
Reproduction, yeah.
And signal processing.
That's right. And Surrey is sort of looking at also the interaction with the visual side of the thing. So it's a combined effort. But in Salford, we are mainly looking at the perception side, and in sort of particular interesting is to look at what do the audience actually want, what is actually classified as a good experience for them. And
so you say Rick's here, who's doing the actual auralisation kind of component of this project. So.
Yeah, so you can talk to him. I think you are doing a demo as well, isn't it?
Yeah.
Yeah. Okay, so talk to him. You will want to know, and Filippo as well, of course. And we also, in Salford, we are also looking at sort of integrating sort of virtual sort of audio rendering into the virtual environment, the visual side. And we have a wave field synthesis system, and together with an opticon sort of virtual reality system. I think Ian is here somewhere, isn't it? I think Ian is my colleague that sort of worked in this project. So if you want to sort of know more, you can talk to him. And of course, another area that we look at quite a lot is on the soundscape side, and the perception of soundscape, and also the simulation of the soundscape as well. So I think I'm going to stop in here, I think. Oh, no, sorry. We also have a Reading workshop that I mentioned before that we actually run in December 2014, which look at specifically some of the theory of the thing. And but again, I think I would sort of leave to John and Steve to actually look at the detail. So thank you very much for coming today. I hope you enjoyed these 2 days and get something useful. And I do hope that you can give us some more ideas sort of, for our future work. Thank you.